Alright everyone, welcome to the first and last installment of Cadence Operations Research Tutorials. We're going to go over some basic simplex graphical analysis whatchamacallits, and I'm basically going to leave all the examples the same, except I'm going to change some names around to make it a little bit more PC, politically correct. Alright, so instead of Betty, let's call this person Chavez. So Chavez owns 150 acres of land. They are going to plant each with wheat or corn. Each acre planted with wheat yields $400 profit, and each with corn yields $600 profit. The labor and fertilizer used for each acre are given below. 200 workers and 150 tons of fertilizer are available. How can Chavez maximize profits from their land? Okay, so the Z right there, that'll come after I explain what the X1 and X2 are. So X1, we're calling that wheat because, wheat was mentioned first in the problem, so I made X1 wheat and then X2 corn because, they talked about wheat, then they talked about corn. It really bothers me how on the table the first column is corn and then wheat. It's like, I don't know, I feel like it's whatever. The column did not go in the exact order that the problem did. But I shall stay true to the problem and say X1 is wheat and X2 is corn. So, from that, we see wheat yields $400 profit, so there's 400 X1, and corn yields 600 profit, so that's 600 X2, and you just add them up to get the total profit of both. And because there are 200 workers available, the labor is restricted to 200 workers, with corn getting 2 workers, that goes to X2, wheat getting 1 worker, that goes to X1, so we have 1 X1 plus 2 X2 is less than or equal to 200. And for the fertilizer, there's 150 tons of that available. So for corn, it takes 1 ton, and wheat, it takes 3 tons. Just reverse that order around, and we get 3x1 plus x2 less than or equal to 150. 3, 3, 1, 1. All right. So there's 2 inequalities here. We want to find the point where those 2 lines written or drawn in that little sub corner of the universe. Those lines should be dotted, by the way, but I am a rebel. And also the line in the middle, that's the iso profit line. Right there. Notice how it goes in between the 2 constraint lines for fert for fertilizer and workers for you know what that means. And yeah, it goes between them because the slope is in between both those lines because it's where the lines intersect. So what we're going to do to actually find where those points of intersection is algebraically, we're going to set these 2 homies equal to each other. But first we're going to solve for x2. So yeah, we solve for x2, and then we set the x2's equal to each other. And you get some stuff like this. Yeah, just digest that. We go from there to there. And we see that when x1 is 20, that's optimal. So we can just plug 20 back into these 2 things. So let's just plug 20 into there. So 200 minus 20, that's 180 divided by 2, that's 90. And let's plug 20 into there. So 3 times 20 is 60 minus 150 minus that. So 150 minus 60 is 90 as well. So we got 90 and 90. Alright, so I guess that means we got an optimal solution at 20 comma 90. And we can plug those home skillets into this profit equation. And we get a Z equal to 62,000 monies. So, yes, that is the first part of how can Chavez maximize profits from their land? That's how you do it. System of inequalities become inequalities. Substitute, it's all good. And next, what happens if 50 more tons of fertilizer become available? Well, the fertilizer one is the second equation right there, or yoink. So it's right there. So if we just change that 150 to a 200, we basically get what we want to get if we do the same process. So that's what this is right here. Yeah, sorry, Androids don't focus that well. It's an S6 Edge actually. But yeah, so we do the same thing. If there's 50 more tons of fertilizer, then well, we get x1 of 40. Just by setting them equal, solving for x2, setting them equal, and then power of algebra right there. Thank Euclid or something. So yeah, 40. Then we plug 40 back into this. Well, let's see. 200 minus 40, that's 160. 160 divided by 2, well, that's 80. Well, how about we try here? Well, 40 times 3 is 120. 200 minus 120 is 80. So we get x2 equal to 80 for both of them. That's really good stuff. So we got 40, 80, optimal. And then we shove it back into the equation over yonder. Yeah, that one. And we get a z equals 64,000. Now, you're probably wondering, like, oh, well, we added 50 more tons of fertilizer. Why are we only getting $2,000 more out of it? Well, the thing is, we really have to pay attention to this right here. So notice that $400 for x1 and $600 for x2. Well, so the thing that costs or gives us the most profit is x2, which is corn. So the thing that gives us the most profit, that's corn. And corn requires the least amount of fertilizer. So fertilizer really isn't that big a deal for corn to begin with anyways. So adding even more fertilizer, well, you're not really helping out the corn that much, because compared to the wheat, the corn was already doing better off to begin with. So that won't really change anything too much. Now, what happens if 50 more workers become available? Well, similar scenario. We are just going to replace, before we replaced that with 200, now we're going to replace that with 250, because this is the worker line right there, the top one. And similar process of solving for x2's. There they are right there, 1, 2. And then we set them equal to each other. We get x1 equals 10. Now we plug that x1 equals 10 back into here. So 250 minus 10 is 240, divided by 2 is 120. And how about that? So 150 minus 30 is also 120, so we got x2 is 120 both times. Perfect. So notice there's less of the wheat, more of the corn, which means our profits are going way up by a good sum. It's about a good amount right there. That's more money than I have for sure. So yeah. Workers are more important to this operation than fertilizer. How about that? Makes sense, because the thing that requires or gives the most profit requires the most workers and the least fertilizer. So makes sense that increasing workers and will do more for you than increasing fertilizer. So that's just an intuitive approach to it. Let's see. Now what happens if 100 more workers become available? Well, pardon my hieroglyphics, but right there, let's just ignore the world right now. So x1 plus 2x2 less than or equal to 300. Notice that used to be 200, but we said 100 more, so that went from 200 to 300. I know, it's high level stuff. Yeah, math is so hard. So negative x1 plus 300 equals negative 6x1 plus 300. Well, we can just cancel those 300s. We know x is going to be 0. So when you have 100 more workers available, you don't even want to use the wheat at all. The more hands you have, the more corn you can get. So we're maxing out on corn here with 150 acres worth. Going amazing. Look at that. And that gives you so much more money. That is the 1% right there. Wow. Gotta tax them. So, look at that. Is there no laugh track on here? That's a shame. Let's see. Yeah, 100 more workers, 0 corn. Call it a quarantine. Okay. What happens if delta more workers become available? Figure out the ranges where the current basis or binding constraints remain optimal. So this is the too much information for your wonderful eyes. So before we just kept adding the amount to 200. So 50 more, that was 200 plus 50. 100 more, that was 200 plus 100. Well, delta more, that's just going to be 200 plus delta. Then we're going to follow the same exact process of, well, setting them equal to each other and finding the x1s. So what happened was, when I first did this assignment, I was very lazy and I didn't actually write anything out. So this is me going back and being space efficient. See, we're starting here and we're just logically following the path to the left. We're going in a positive orientation, trying to stay mathematical with it. So negative 3x1 plus 150 equals negative x1 over 2 plus 100 plus delta over 2. And fractions are ugly, so we multiply it all by 2. And then, well, we combine some like terms. We do it again. And we isolate, just like we're all doing right now. Social distancing, everybody. My daily life. So, we have x1 equals 100 minus delta over 5. What do you do with this x1 and deltas and such? Well, we're going to shove it back into the other equation. So we know x2 less than or equal to negative 3x1 plus 150. Well, we got an x1 in terms of delta, so now we can plug it in and find x2 in terms of delta. So that's exactly what we do. We say x2 equals 3 delta minus 300 over 5 plus 150. Notice I just took the 100 minus delta over 5 and I multiplied it by negative 3. Yeah, right there. That's what I did. So that times negative 3, so that becomes 3 delta minus 300 over 5 plus 150 plus 150. Staying with me, people. Okay. And then I went crazy and actually forgot to correct one mistake that I made. Oh well. So that's actually equal to 3 delta plus 450 over 5. Alright, so yeah, 3 delta plus 450 over 5. Because 150 times 5 is 1,050. No, it's 750. 5 times 150 is 750. And then we subtracted 300 to get 450. And yes, that is what occurred. So now we stop being crazy and just use a different page. And I figure, well, x1 and x2, they had to both be greater than or equal to 0. So I just set these things that I got for x1 and x2, and I set them greater than or equal to 0. I don't know what he's doing down there. Sometimes I just write, and I just don't care where things go. Alright, this is a bit more orderly. So yeah, just basic algebra multiplied by 5 is because it's 0, so that just goes away. And now we can subtract 100 on the top boy, female thing, g. 100 minus delta, so that's going to add the delta. So delta is less than or equal to 100. Similar story, we're going to say 3 delta greater than or equal to negative 450. You just divide the 450 by 3. You could say delta is greater than or equal to negative 150. So we got negative 150 and we got 100. That looks kind of like an E, but I swear to you, it is actually a legitimate 0. Yes, I do not write in riddles. So, yeah, that's... Ooh, I mean, I don't know why this seemed so much harder in the beginning of the semester. It's really just simple stuff. You just do the same thing we did for all the other times, and then we just set them greater than or equal to 0. Similar story for the different constraints of what happens if delta more tons of fertilizer become available. Figure out the ranges where the current basis or binding constraints remain optimal. And yeah, similar story, and I reversed the order of them for no reason, and I labeled that as a 1. That's supposed to be a 1 that I circled. And then the second step, you isolate the y. I'm no longer using x1s and x2s because this is a free country. So y less than or equal to negative 3x plus 150 plus delta, and y less than or equal to negative x over 2 plus 100. And we can set those things equal to each other. Yep. Went too far. Did I? Negative 3x plus 150 plus delta? It's up here. I stopped going bottom up, and now I'm going from the top down like a regular American. Okay, negative x over 2 plus 100, check. Negative 3x plus 150 plus delta. What if I just gave you the aerial view? It's probably a lot easier. Alright. Yeah, but then it's so small. I write so small sometimes. Yeah, negative 3x. So we're just going to combine some stuff. I multiplied it by 2 again because fractions. And then 5x equals 100 plus 2 delta. X equals 20 plus 2 delta over 5. And, well, just plug that into y. So we got 20 plus 2 delta over 5. And we're plugging that into the one that doesn't have a delta. Because that's just how substitution works, really. So 20 plus 2 delta over 5. So we're going to have less than or equal to negative 20 plus 2 delta over 5 over 2 plus 100. Well, that's exactly what happened right here. So we got the two things again, and now we're going to set them greater than or equal to 0. So you subtract 20, 2 delta over 5 greater than negative 20, multiply it by 5, divide by 2, and delta greater than or equal to negative 50. And then there's that mess. So what I did in my head was I just subtracted 100 and then multiplied by 2 at the same time. So it's negative 20 minus 2 delta over 5 greater than or equal to negative 200. And then you can add 20. You get negative 2 delta over 5 greater than or equal to negative 180. And then we just multiply by 5 and divide by negative 2 to get a delta less than or equal to 450. And yeah, the delta is in the range of negative 50 to 450. I repeat, delta is in the range of negative 50 to 450. That is where it's allowed to be. Alright, I've explained sensitivity analysis of the constraints and other things and such. Let's dive right into the assignment, because this is honestly easier than the sensitivity stuff. So, Bonita Beach Brewery produces beer and ale. Beer sells for $5 per barrel, and ale sells for $2 per barrel. Producing a barrel of beer requires 5 pounds of corn and 2 pounds of hops. Producing a barrel of ale requires 2 pounds of corn and 1 pound of hops. 60 pounds of corn and 25 pounds of hops are available. Formulate an LP that can be used to maximize revenue, and then solve the LP linear program graphically. Alright, so I'm going to say X1 is beer and X2 is ale. Realistically, maybe I should have gone alphabetically. Maybe I should have said that ale is X1 and beer is X2. You know, A B, but the question wrote beer first and then ale second. So beer and ale, beer sell five, ale sells five. So it seems to me like the chronological notation of things should be X1 is beer and X2 is ale. And then Z, well, that's about the money again. So we said X1 is beer.